Non-metallic sheath cable, better known as Romex, has been used in the residential electrical industry for many, many years. It is a safe product, like anything else properly installed. There are certain code requirements and there are certain new code requirements that need to be reviewed. We hope this little video may help you out a little bit in reviewing some of these items. It's always good to have a review. We ask that you look at some of our other channel videos, like, subscribe, and support this channel where you can. Thank you. So why is it known as Romex? Well, non-metallic sheath cable is a staple of the residential and light commercial wiring in the United States, and it's been that way for many years. While many in the trade use the brand name Romex interchangeably with the product's type, it's important to understand that there's a specific classification that's defined in the National Electric Code. The primary reference for these rules in the National Electric Code are in Articles 334, non-metallic sheath cables type NM, NMC, and NMS. When electricians refer to Romex today, they commonly mean type NM, frequently supplied with conductor insulation types that support 90-degree operation for derating calculations and commonly marked NMB. The B suffix seen on product markings indicates conductor insulation type suitable for 90-degree ampacity adjustment calculations, not that final allowable ampacity. This is a little bit of confusion for a lot of folks, so we want to clear that up before we go too far into this program. Now, older NM constructions sometimes used paper fillers, but modern type NM cable, often marked NMB, has a flame retardant non-metallic outer covering and conductor insulation types identified for use in residential branch circuit wiring. The older paper fill designs are no longer the norm for typical Romex or NM installations. So Romex Cable Corporation of Rome, New York is where all this kind of got started. The Romex name comes from the Rome Cable Company of Rome, New York, and who originally produced the cabling. Why the X is at the end of the name is a mystery. The company was an industry leader until it filed for bankruptcy in 2003, and its factory has been demolished in 2010. Rome Cable Corporation was also a major source of aluminum wire that was produced by its parent company, Alcoa. As most of us are aware, aluminum wire is inferior to copper wire, and its presence is considered to be dangerous in homes. In 1964, Alcoa was court-ordered to divest itself from Rome Cable Corporation. So that's how we got Romex. As with any product, there's pros and cons with the use of NMB cable. Some of the pros listed we have are it's lightweight, smooth to pull, easy to cut, and the sheathing's easy to rip, and it's pretty easy to handle. The cons are the following. It's not for exposed use, and it's mostly not for outdoor use. Cannot be used in drop sealants. We'll talk more about that later. It's not fire resistant, and the sheathing is easily pierced. It's an important point to consider that the outer sheathing of NMB cable or Romex, the color coding we see that we're used to seeing, has absolutely nothing in the code as to back up what the color needs to be. The manufacturer can make it whatever color they want. Fortunately, most of the manufacturers have gotten together and they got kind of a consensus going on different colors. So, and there's new colors out there. I've seen pink, kind of a teal looking. And although these new colors are not required by the NEC, most manufacturers have started adopting changes to be more consistent. While not yet universal, this shift suggests that the industry is moving toward a broader acceptance of new color schemes, and electricians and inspectors need to always be aware of the outer sheathing and actually read it and see what size conductors they're dealing with. Don't depend on the color. So as with any product, there's uses that are permitted, not permitted, and these are going to be found in the National Electric Code, section 334.10, 334.12. If you do not have a copy of the code, we do have a link provided in the description, and you can get that. Also, there's a couple other product books down there you might want to look at. They're highly recommended. So the uses permitted and not permitted are sections that we need to keep in mind as we're doing our work. So uses that are permitted for Romex or NMB. And we need to keep in mind that I'm referencing the 2020 NEC section 334.10. There's the companion code, the International Residential Code, which we also have a link for, but the language is primarily the same. Okay, so typical uses are for 1 or 2 family dwellings and they're attached or detached garages and storage buildings. Multi-family dwellings of specific construction types, typically type 3, 4, and 5. What we're talking about is wood frame construction, provided the cable is concealed in walls, floors, or ceilings with a 15-minute finish rating. And typically the gypsum board is going to provide that. Now in some cases, other structures that are not necessarily wood frame construction, as they're classified in the building code, may allow some use of Romex, but it does have specific requirements. It is allowed to be fished into air voids of masonry block or tile walls where it's subject to protection where there's not any excessive moisture. Moisture is the prime driver in some of the code provisions concerning NM cable. Uses not permitted are also covered in both the IRC and the NEC. In the NEC, look in section 334.12, also 334.10. Uses are not permitted in any dwelling or structure not specifically permitted where it's exposed and dropped or suspended ceilings in non-residential buildings. It cannot be used as service entrance cable. It cannot be used in commercial garages, theaters, motion picture studios, or other hazardous locations. Cannot be embedded in poured concrete, cement, or any type aggregate. Again, we're talking about moisture issues. Cannot be used in wet or damp locations. For these, an electrician might choose type NMC or UF cable, or a different wiring method like MC cable entirely. We need to look at the code and keep these things in mind, especially the wet and damp location requirements. Key takeaways that we need to have for field application of NMB. Now, NMB is your go-to for the standard indoor residential wiring in normally dry locations. NMC, the specific choice is for permitted wiring in damp and corrosive indoor locations, and certain masonry installations were installed in accordance with Article 334. It is not, again, it is not a direct burial cable. Now UFB, that's the correct type of outdoor runs in direct burial when a cable not in a conduit is used. UFB is a distinct cable type and is the proper direct burial cable alternative. Temperature ratings have to be kept in mind. The 90-degree marking on NM or NMC is used for derating calculations per Article 334. The final ampacity for the installation may be limited to the 60-degree column, depending on terminations and article requirements. So keep this in mind for code compliance. If you have any questions, contact your local authority having jurisdiction, electrical inspector, building inspector. Now, one of the key things that our inspectors look for, especially with Romex, is protection from physical damage. And we're going to be in the National Electric Code, the 2023 editions, in Articles 334.15 and 334.17. And there's also some other pertinent articles that need to be looked at. But in both exposed and concealed locations, the NM cable must be protected from physical damage. Exposed cables must closely follow the building surface or run on running boards. In other words, anything that can damage that cabling needs to be a protection. In unfinished basements or crawl spaces, cables running through board holes and joists are considered protected, as are cables running parallel to framing members when set back at least 1.25 inches. Now that 1.25 inches measurement comes into play quite a lot when we're talking about NM cable. If this distance cannot be maintained, and a steel plate at least a 1/16 of an inch thick must be installed to protect the cable from nails and screws. A word of caution, there's a lot of these big box stores that are selling what I call nail guards or nail plates that don't meet the requirement for the 1/16 inch thick metal. They're cheap. You can actually just take them and easily bend them. So be careful what you use. You need to understand how the National Electric Code is there to help protect the health of the nation. Along the same lines of protection, we got to make sure we properly secure and support the cable. It's crucial to preventing strain on connections and protecting the cable from damage. The general rule requires that NM cable be secured at intervals not exceeding 4.5 feet. Now, the securing also has to be done within 12 inches of every box, cabinet, or fitting. The hole being bored is not the protection. All right, when running cables through bored holes and framing members that are spaced no more than 4.5 feet apart, the cables are considered supported. However, they must still be secured within 12 inches of the termination point, and that's the point I'm trying to make. For flat cables, such as typical 12-2 wire, staples must not be applied to the edge, as this can compress the conductors and damage the insulation. And only listed fittings such as staples, straps, cable ties, stackers, identified for support should be used. I've seen this too many times on construction sites, and most of you have too. We have to remember about bend radius. That also applies to Romex or NM cable. To prevent damage to conductors' insulation, the bend radius requirements that are listed in 334.24 state that NM cable must not be bent tighter than a radius of 5 times the cable's major diameter. Now, this can be subjective and is up to an inspector or the contractor to make a decision on. But a lot of times, if it looks like it's been bent a little bit too tight, it has been. Okay, we've covered a few things, so let's talk about how we're going to tie all these conductors together. We have quite an arrangement of different products out there on the market. Specifications in the National Electric Code section 110.14 gives you some criteria. It says connectors must be listed by a recognized testing laboratory, such as UL or ETL. The temperature ratings must match or exceed the conductor insulation. And there's other different limitations with each type wire nut that's used. So look for the UL mark, CSA for Canadian applications, NEMA ratings, ROHS compliance for environmental safety, where that applies. It's always interesting to look at the different wire nuts or twist connectors and take a look at them, just see what their specific requirements are. There's listed in the equipment. Now, the gray wire nuts, these nuts have features for handling 22 to 16 gauge wire up to about 300 volts. I think what we commonly see are the orange, the yellow, and the red. I believe yellow and red are probably the most common that we see on most residential sites. Wire connectors are essential electrical components that join two or more wires together to create secure, reliable electrical connections. The right connector type ensures electrical safety, prevents failures, and meets code requirements. Understanding the different types of wire connectors available helps you to choose the safest and the most appropriate option for your specific electrical application. So here's the part of the program where usually everybody turns me off because we're going to talk about math, right? But the most misunderstood rules are the rules concerning ampacity and derating and the NMB 90-degree ratings. Just got to be in the right columns. As you see in this photograph, somebody actually highlighted this. I strongly recommend you also, if you're going to take an exam, to highlight the correct columns. Again, this is perhaps the most confusing rule in Article 334 concerning ampacity. The 90-degree rating can, however, be used for ampacity adjustments and correction calculations or derating. For example, when bundling multiple cables together or running them in a high temperature environment, you start the derating calculation from the higher 90-degree ampacity value. Just remember though, the final calculated ampacity must not exceed the value listed in the 60-degree column of table 31016. Again, if you're doing primarily work with NM or Romex, then you might as well just highlight the 60-degree column of table 31016. That way you make sure you go to the right area and get the right information. A common question is, can I use the 90-degree ampacity for 12-2 NMB wire? And the answer is no. Like I just said, we have to use the 60-degree column of table 31016 for 20 amp, which is 12 EWG, due to terminal ratings. The 90-degree value is only used for starting the derating calculations, and overcurrent protection is further limited in NEC 240 4D and to 20 amp for 12 AWG branch circuit. This is not that confusing. It just takes a little bit to kind of, let it sink in. The light bulb does come on. So just hang in there. Remember to subscribe and support this channel. When bundling more than 2 NM cables with 2 or more current carrying conductors through the same board hole in wood framing for a continuous length longer than 24 inches, you must derate. And here is how you apply that. You count the conductors, determine the total number of current carrying conductors. For example, if you have 3 12-2 cables, then you have 6 current carrying conductors. You notice we did not count the equipment grinding conductors. Find your starting ampacity. Look up the ampacity of the conductor in the 90-degree column of table 31016 for 12 gauge wire copper. And this will be 30 amp. Then you apply an adjustment factor. Use table 31015 C1 to find the adjustment factor. For 4 to 6 conductors, the factor is 80%. So you calculate the adjusted ampacity. So you multiply the 90-degree ampacity by the adjustment factor. Now for our 6 conductors, there's 3 12-2 cables. We have 30 amp times 80%, which is 24 amp. And then finally, we check this and we compare the results to the 60-degree ampacity. The 60-degree ampacity for 12 gauge wire is 20 amp. Since our calculated 24 amp exceeds this value, the final allowable ampacity must be limited to 20 amp per NEC 334.80. I think you got it. So let's take on a few specific questions concerning NM. And please remember to subscribe, like, and support this channel. Shoot me a comment, shoot me an email. Let me know how you're doing. Good old staples. How often do I need to staple Romex wire? Well, according to the National Electric Code, and we're going to be in 334.30, you must support and secure the cable at intervals not exceeding 4.5 feet and within 12 inches of every electrical box or cabinet. Now, I love these cable stackers. I think it's the way to go. But everybody's got their own opinion about everything, right? Just keep a few things in mind. Cables cannot be placed side by side on a 2x4 and maintain the required 1.25 inch setback. We're going to be talking more about that in a little while. Cable stackers kind of solve that problem by maintaining their clearances for bundles, and they allow the conductors to breathe. Whereas, when somebody just takes a staple and takes a zip tie and zip ties everything in there tight, there's no space in between, so there's no air moving. But staples must be used only when the size and number of cables and the instructions on the cable packaging allow it. So typically, if you see the stackers, like the one we see here in this picture, it's going to limit that to 4. You can't try to force more in there. And again, this is going to be on the packaging. Now, the zip ties or the cable ties, however you want to call it, are a great tool to use. They keep everything very neat. But just don't don't over tighten them, especially if you're using the tool to cut and tighten these down, because you can cause damage to the NM cable. Uh, Also keep in mind, how your staples are being used. And again, you got to be careful how many conductors you put in a little bundle. Now, we mentioned this before, and we'll mention it 1,000 more times, especially if you're watching my videos, because you got to keep in mind that moisture is a serious issue when it comes to NM cable. So we have to be careful. Article 100 defines wet locations. Uh, I think the biggest thing I see is we'll have in residential construction, you'll have the instance where you have like an island sink in the kitchen, and they'll run a conduit out there and they'll fish a cable. Now that should be a UF cable going out to that island, but it never fails. We end up seeing somebody putting Romex. So you have to be careful of that, because that is considered a wet location. There will be a link provided to our other video that we have, a more in-depth video on this issue of edge of wood and protection of conductors in wood framing. So we encourage you to take a look at that. Remember to subscribe to this channel. So is Romex allowed in a commercial building? The answer is it depends. You got to look at the NEC articles depending on the type of construction. We see quite often we'll have a commercial building such as what you see in this photograph, where it's a metal building or otherwise not rated the same as wood frame construction. But the interior may be wood frame because it's non-load bearing. Now, you can run the Romex as long as it's protected, so as long as it's hidden. Quite often what we'll see is someone will go in, they'll frame all the walls up with wood frame construction, and they'll run Romex through the walls, but when they come up through the plates above, they will immediately set a metal box, a 4x4 box, and then take off with MC cable after that, especially if they're going to have drop ceilings, because you cannot have Romex above a drop ceiling. So that's one of the considerations you have. And as we just said, can NM cable be above drop ceilings? And that short answer is going to be a no. If you can lift out a tile and easily see Romex above on a commercial building, you're not going to be permitted to do that. The only exception would be if you had like a basement on a residential structure and somebody did a drop ceiling. You're actually allowed then, because the exception is for residential buildings. But primarily, the answer is going to always be no, you cannot run Romex above a drop ceiling. Can you splice Romex? Well, of course you can, but you've got to be in a box. You can't just hide it in a wall like you see in this photograph. Time and time again, we see in residential construction, especially on renovation projects, where somebody just kind of took the wire nuts, and if you're lucky they did the wire nuts, most of the time they just twist the conductor together, and if you're lucky they put some black tape over the top of it. But Romex must be terminated in an approved enclosure type. Now, Romex in residential attics always brings up several points, and you'll see some of these in the photographs. Again, we're talking about protection. We want to protect the conductors. If somebody's crawling up through a scuttle hole in a residential building and they're dragging their feet around right close to that edge, we want to make sure all those conductors are protected. So that's why the code requirements that we have are in place. So, but where this space is not accessible by permanently installed stairs or ladders, the protection is only required within 6 feet of the nearest edge of the scuttle hole or attic entrance. Now, we spoke a few minutes ago about derating. So an important consideration is when you install multiple cables together in bundles, right? So Article 334.80 addresses this, and it states that where more than 2 NM cables containing 2 or more current carrying conductors are installed without maintaining spacing between the cables through the same opening and wood framing, that is to be sealed with thermal insulation, caulk, or sealing foam, the opacity of each conductor shall be adjusted in accordance with Table 310. A lot of times what we see is someone drills a hole in our top plate, or double top plate especially, and they'll run, as many conductors as they can in that hole. Typically for Romex, you want to limit that to no more than 2. That's just a good rule of thumb. After that, you have to derate. And if you have long spaces and areas with like a long extension of pipe greater than 24 inches, there's even more considerations that have to be taken into play. Can you run Romex in pipe or in conduit? Again, it's an it depends kind of thing. Why are you doing it? If you're running in a piece of conduit to keep it protected, that's one thing. But if you're running it just for a convenience, and that's another. What you have to consider with Romex is heat. Heat is the enemy, just like moisture is, right? So you got that jacket there and it's going to produce some heat. If you got that jacket inside a real tight conduit, there's no place for that heat to go. And the next thing you know, you got damage to the conductors. So that's what you're worrying about. You got to get rid of that heat. So the key takeaway here is that Romex is not recommended to be in a conduit unless it's there just for protection. But again, this is one of those where you need to get with your authority having jurisdiction to get their opinion. Now, we touched on this a little while ago, but it's a good question that came in on one of my comments. And how many Romex can you run through a single opening? Typically 2 is what you want to limit it to. Once you get more than that, you got to start running into trouble. So that was answered in an earlier question. So when you're drilling the holes, usually you're going to drill a 5/8 or 3/4 inch hole, and that'll run, a couple of 12-2s or 14-2s, and you're fine. But if you're going to be running like 10-2 Romex, then you need to have a little bit larger opening. So usually what I do is a 7/8 inch or a 1 inch drill bit size is what I'll use. The extra space ensures that the wire can be pulled without too much friction. It also gives a good basis for protection of the conductor. Okay, here are a couple of really good ones. So NM is not suitable as a flexible cord or with the plug on the end. I still, from time to time, as an inspector, see this on residential sites where they'll take some Romex and they'll hook up the dishwasher and they'll run the Romex under the cabinet, and they'll have a nice little GFCI receptacle there, and they'll put an end on that Romex plug. That is not acceptable, and it's in the code, NEC 11038. A couple other considerations concerning Romex. Well, there's a lot of them, but I'm going to name a couple. First, don't overdrive the staples, and don't turn your Romex on its end and drive them. Make sure you use listed grommets wherever you have holes in metal framing. I see this quite often, especially on things like a garbage disposal where they don't put any kind of grommet. I hope you take the time and kind of look at some of the other videos we have. We're going to have one that's really in depth about copper clad aluminum. As most of you know, in the 2020 NEC and the 2021 IRC, copper clad aluminum is now permissible. There's a lot of issues that have come up with that. It is an acceptable product. It just has to be installed correctly. There are some key takeaways that you need to look at with it. So I encourage you to go to that. We're going to have a link in the description. So let's just do a quick run through on some issues. Common violations that are usually written up by inspectors. No staple or other fastener within 12 inches of a box, cabinet, or a fitting. That's pretty common. Open runs with support points spaced more than 4.5 feet apart. Overdriven staples that pinch, flatten, or cut into the sheathing. Flat NM cable stapled on edge rather than laid flat under the proper fastener. Too many cables crowded under one staple or support clip. Cable hanging in vertical stud bays with no compliant support near the termination points. Installers just assuming that the board holes remove the need to secure the cable near a box. Improvised support such as plumbing, duct, and ordinary zip ties that are not identified for cable support. Zip ties are kind of the wonderful product, but it gets misused quite often. neat staple spacing but missing cable connectors, missing nail plates, or other related defects. For the nail plate issue, the simple rule of thumb is if it's close, just put a nail guard on there. Don't get turned down on an inspection because of something like a nail guard. And that concludes this series that we have on NM cable. We'll have more extended series in the future, and we ask that you keep an eye out for that. If you can subscribe to the channel, like and share, provide me any comments. I would greatly appreciate it. Thank you.